Oh my god. This is so heavy. Oh. Hello ladies and gentlemen, this is my Speedboard project. This is inspired by the Speedboard Kickstarter project that has by now led to nowhere. There was also this other video on the internet way before the Speedboard was announced that had a similar principle. I was some student from some university built this for his thesis, I think. But I started this way back when the Kickstarter was still running, and I wanted to build my own one, and I figured I might try to build the fastest electric skateboard ever. I have failed so far, however, the platform itself is quite capable. And I'm gonna show you around the thing. I developed this, drew it up in CAD, and then built it, and then did some iterations on it, especially with the linkage for the front wheel. But I'm gonna show you around and explain everything. I'm going to do a quick overview right here, but I'm going to do a separate video with a technical deep dive into the design of the board at a later stage, where I will explain every part in detail and every thought process behind everything I did and all the iterations and everything. So look forward to that. Okay, so quick design overview. This was my first CAD model. The first prototype that I built was basically exactly like this. I used some 50 by 20 steel tubes welded together, building this frame. This I think is 54 by 50 U profile, something like that. Just cut to a small piece and then angled off the edges. These front linkage arms were 3D printed, same as these axle holders. The entire wheels and the sprocket in the rear and the brake disc in the rear, as well as the axles, were wheels for a pit bike. I just ordered the wheels and all these parts off eBay as spare parts, and then measured them and drew them up in CAD. For the front wheel I had to redo the spokes to put in a narrower wheel hub, but with the wider rim. Yeah, I had to do some machining on the hub, but nothing too crazy, just to get it as narrow as possible so this linkage would work properly, because obviously we need a narrower distance in the front than we have in the rear for this entire thing to work properly. Also, something that's not modeled here, just the carrier plate, is the rear brake. There's the carrier plate for the rear brake. I had also the brake of the pit bike basically mounted on here, and then just running a hydraulic brake line to a piece of motorcycle handlebar that I cut off a bent handlebar that I had laying around, and mounted the pit bike brake reservoir, or brake pump, on that handlebar. That was my brake control. I really wanted some hydraulic brake as backup, because first of all, the first tests were without a motor, and second of all, I really don't trust just having the electronic brake. I really want two redundant systems for braking, especially when going faster with this thing. Other than that, the top and bottom plate were just wood, and the first prototype I built without the motor. This later I just cut the wood right here and then welded on these two plates and put the motor there. I did the first couple of test rides on the hill right in front of my house, but it was hard because of the limited steering angle.
Get real stable at higher speeds. Okay, it's also stable at lean. I was just weirded out at first.
So as you could see, it was basically functioning. The steering worked, the braking worked. It was a bit hard to get on because of the limited steering angle, so you needed some speed for it to ride stably. Next up, I called a friend and we drove out to this bigger hill, and I tried riding the thing down there. Yeah, and this was quite interesting to find out how the whole thing handled at higher speeds, and I could get used to riding the thing. It was quite fun. Obviously, I wore my entire motorcycle gear because, first of all, I didn't really know how well I could ride this thing at higher speeds. And second of all, I didn't fully trust the 3D printed parts of the front tire linkage. And quite honestly, I was surprised that they did even hold up this long. And to be frank, I expected them to break off any moment. I was really cautious to not ride through bigger potholes and stuff like that. But it worked out well, and we got up to speeds of about 50 to 60 kilometers an hour here. The brake also worked well. And my friend, of course, driving carefully behind me to keep other drivers off me and to secure the road. It was then time to put on the motor. The motor that I used was this 120 by 90 Outrunner brushless motor with 80 kV and advertised 18 kilowatts of power. Together with the motor, I ordered, I think, this Alien ESC, which was the worst decision I could make in the entire project. And you'll see later why. Either way, I put in this ESC. The programming is horrible. There's basically, this ultra bad Chinese program for the computer, and it's not clear what button does what, and you can't really change some settings, and then other settings are described badly, and it's just a horrible experience. And the ESC itself doesn't properly work as well. I was explicitly looking for a censored ESC and motor combination so that I could start riding from 0 RPM with proper power. And yeah, it later got obvious that this ESC just can't do that for some reason. I used a thumb throttle off eBay that was meant for e-bikes and just also mounted it on the handlebar here. And I used a small Arduino Nano to just convert that 0 to 5 volt potentiometer signal into a PWM signal for the motor controller. And that was that. The motor had just some sprocket screwed on the front of it, and I used a 428 motorcycle chain to drive the rear wheel. For the batteries, I just used 4 1800 4S batteries that I use for my drone racing stuff, and I put 2 of them in series and 2 of them in parallel, so it was basically 8S 3600 milliamp hours.
Oh, fuck. Oh my god, it has so much torque. And it doesn't really work.
As you could see, I was having trouble getting on it, and the ESC was having trouble starting up the motor if it wasn't already running a bit, or it had absolutely no load on it. It could do that, but when I was on there and it had to accelerate the entire board plus me, it was having trouble doing that. So I decided to drag it up the mountain a bit again, and starting to roll down and then set off from there.
No fucking way. This is a really steep hill, man. And I'm only like half throttle, man. And it's windy up here.
I went pretty much full throttle here, and I later found out that that was about 40 kilometers per hour. It looks kind of fast. It almost looks like 50 kilometers. Maybe it was slightly above 40. Yeah, but everything seemed to be working quite fine. see that I was still running the 3D printed linkage for the front wheel, and it seemed to be working quite fine. I was surprised it was still holding up, but yeah. And it did hold up until it didn't.
Oh my lord, it broke. Fuck, just... Oh god. Oh, the pothole broke it. For fuck's sake, man. And that screw came loose. Why did that screw come loose? I see that as an absolute win.
After this, I went back to the drawing board, and as you can see, I do have quite many versions of the Speedboard since. What we just saw was Mark 1. After that came Mark 1-1, and that's this one. And that's the one I have right now, with these CNC milled aluminum parts right here. I ordered these parts from PCBWay. They offer awesome CNC machining. They were shipped 2 weeks later. And the axle holders, I machined them myself on a manual mill, but it worked fine. I pressed in the bearings into the arms and assembled everything, and this is how it looks now. I then met up with another friend and his girlfriend to try out the Speedboard again. This was quite a bit later, probably around a year later, actually. And to be very honest, I was scared a bit. This was also the first time I upgraded a battery, and I was running 4 6S, I think 6000 milliamp hour batteries. Again, 2 in parallel and 2 in series. So it was basically 12S, 12,000 milliamp hours, so 12 amp hours. For some reason I was just not feeling it that day, and I offered my friend a ride. So we swapped vehicles and he got on the Speedboard. As you can see, he was having trouble starting from zero again, which was, you know, the problem I had all along with this ESC and motor combination. So he held on to the back of his motorcycle and I helped him accelerate to a little bit of speed, which then enabled him to carry on himself from there. was honestly awesome seeing the Speedboard be ridden properly from outside. I think we reached speeds of about 60 kilometers per hour here. But the ESC didn't like going up that hill at that speed, and I'm just going to let you watch what happens next.
Oh, es brennt.
Es brennt?
Fuck.
Fuck die Akkus, Alter.
Fuck, wir haben den Schraubenzieher oben gelassen.
Schraubenzieher. Soll ich holen?
Ja, das kannst du vergessen, das ist...
Oh, fuck die Akkus.
Nein, Digga. Mathis, geht's dir gut?
Ja,
He was fine, and he even went and got a screwdriver from the car so he could screw off the top plate of the Speedboard to unplug the batteries and maybe save at least those batteries from burning up, because it seemed so far as if only the ESC had caught fire. What I didn't know, my friend's girlfriend had a little screwdriver with her, so we unscrewed the top deck and we unplugged the batteries.
Reiß raus den Akku.
Kurwa!
Hier, setz ihn mal. Setz ihn auf. Danke.
Yeah, so as you could see, this Chinese ESC was the worst thing ever. Unfortunately, I didn't know when I ordered it because I didn't properly do my research. I have learned from that, and the next ESC that I'm going to buy is going to be a VESC, the official one from Tramper Boards. However, this ESC is incredibly expensive. Well, it's not incredibly expensive, but it's just more than I can afford at the moment, so the project will have to be shelved once again for a bit until I have enough money to get such an ESC, and then I also need to get new batteries somehow. In the meantime, however, I will give you a quick overview over all the other versions that I have made so far. This is a version of the board that I would like to build basically next, because this uses the same parts that I already have. It's just a new frame, and the frame can be built very cheaply. I already have these new parts. Those are 40 by 10 rectangular tube profiles. It has the same parts up front here, same everything basically, same wheels. It just has the motor in a different position, and that allows for obviously a lower center of gravity, and therefore it's a bit easier to get on, and it still has plenty of clearance for lean. So there's that. Yeah, I will probably build that at some point fairly soon. I had a Mark II. This was, I think I made this before I even finished building the first version, but this is very old and is overhauled basically. I had started doing a Mark III where I basically did a custom wheel that I then screwed on top of the motor so I would get a hub motor. That was before I found out about the hub motor that I could buy theoretically, and I'm going to show you that now. I'm gonna not show you that now. First I'm gonna show you this hub center steering version. This has some weird stuff going on here, but yeah, but basically this has one single steering axle in the middle, you know, just like any hub center steering, but it's quite complicated to build, and I'm not sure it's better than the other version. And then there's the Mark V, which is the current best version basically. This has the rear hub motor that I would love to put in the Speedboard. It has a totally revised front end with much cleaner integration of all the parts, and a custom front wheels assembly. I haven't quite finished modeling that here, but I have a clear vision of how this is going to look and how it's going to be made. And yeah, this also has 20 degrees of steering angle. I think slightly more, maybe 21 degrees. And I would love to build this, but I currently lack the funds to do so. It's still missing a few things in the drawing, like, you know, the modeling of the rear brake caliper and stuff like that. But if we look in here, we can see it even has a full array of 21700 cells in it, and the ESC, the BEC, stuff like that, you know. This also has a shortened wheelbase, and together with the increased steering, this would probably handle much better and could drive much slower than all the other versions. So this is what I shoot for basically. That version would pretty much use this QS motor hub motor that I found. I already got a quote from them about a year ago, so that I could have this for a prototype build for I think $250. And if I have the money, I will buy this together with the VESC ESC, and then I'm gonna try and build this latest version. I also have a new way of doing the frame, because I worked at a company over the summer which does sheet metal working, and I had an idea to make the frame much better. I still yet have to model that, but it's basically laid out in my head. Okay, so this was about it. If anyone has questions, just write a comment. If there's any interest in further development, also write that in a comment, and I will probably do further videos on this as soon as I can do anything, you know, if I get money. I'm currently, you know, in university becoming an engineer, so the topic kind of fits, but I'm kind of struggling with financing these projects. Alright, thanks very much for watching, and hopefully see you in the next video.